All right, next we're going to talk about hypothesis testing for one population mean. We had two approaches to this. We only got a chance to talk about one of them in class, and that method was the critical value method. So what I want to do real quick is just remind you what we were doing. So the idea is that you have a population, you have maybe you have a little bit of information about the underlying population. Maybe you have that population standard deviation, maybe you do not. But what you do have is you have a sample from that underlying population, and then from that sample you want to infer some sort of information about the original population itself. So what we're trying to do is trying to determine whether that underlying population has a specific mean or whether that mean is not equal to some value. And so it's called hypothesis testing. So we have some guess as to what's happening with the underlying population, and we want to test it. So the two methods are the critical value method, and that's the one that we went over in class, so the critical value method. And the idea here is that what we're going to do is we're going to split up our region into pieces. We're going to have what we call the rejection region and the non-rejection region. Critical value hypothesis testing comes in three different types. So the first type is two-sided or two-tailed hypothesis testing. So this is specifically where you have your hypothesis, the null hypothesis. The hypothesis that nothing is happening is always that mu is equal to mu naught, and the alternative hypothesis for a two-tailed test is that mu is not equal to mu naught. If it's left-tailed, the alternative hypothesis is that mu is less than mu naught, and if it's right-tailed, you're guessing that the alternative hypothesis is that mu is greater than mu naught. And so the critical value approach is where you have rejection regions and not rejection regions. And the rejection regions, if you have a two-tailed test, there's going to be two of them. It's literally called a two-tailed test because you have two tails, right? You have two rejection regions. If you have a left-tailed hypothesis test, you're only going to have the left tail. The right-tailed hypothesis test, you're only going to have a right tail. Remember that the critical values are included in the rejection region, so those values get included over here. And so that's the critical value approach. So the critical value, the alpha, remember, is the significance, right? You want to determine beyond a certain threshold of significance does something happen or not. And so that alpha is your significance level. And the alpha, if you have a two-sided or a two-tailed test, that area alpha has to be split into two. So that's why each of these areas is just alpha over 2. That way when you add them up, you get area alpha. For the left-tailed or right-tailed, for these one-tailed tests, you don't have to split the alpha up into 2. So you just have alpha over here, alpha over there. Okay? So that's the critical value approach. It's going to be the same idea if you do not know the underlying population standard deviation. You just use the student's t-distribution rather than the standard normal distribution. Okay? That's the same idea. Now, that's one way to do hypothesis testing. And if you don't have a lot of technology, if you don't have R handy, if all you have is the charts, if all you have is the t-distribution, the critical value approach is really the reliable one. Again, if you don't have any technology available. If you do have technology available, you can use what's called the p-value approach. And p-values are a subtle and somewhat tricky thing. So I've included a link here with a good video, in my opinion, a good video that explains the ideas behind the p-value. And the idea behind a p-value is that you start with some observation. That observation tells you something. It tells you what you do with that observation is you compute what's called the test statistic. So if you know the underlying standard, if you know the underlying population standard deviation, then you get, this is going to be a z-test, and what you do is you compute this test statistic z naught. Okay, so that goes here. And with the test statistic, what the p-value tells you is the likelihood, the probability, I should say. So this is the probability of getting data that's at least as extreme as your data set. So given any random sample, what's the probability that that random sample is at least as extreme as your data set? What I mean by extreme is that if you have a sample and your test statistic comes out here at this value z naught, then the p-value, if it's a two-tailed test, the p-value is going to be the area, the probability that your data point is here or to the right, okay, at least as extreme. And if it's two-tailed, you also have to take into account that it could also be over here. Okay, so I still can't draw, sorry, even though I'm now a fancy YouTuber. So it's going to be the sum of those two areas there. So if it's a two-tailed test, that's what the p-value is. Again, the probability of observing results, getting random data that's at least as extreme as your sample data. And it's the same idea with a left-tailed or a right-tailed test. Okay, so your p-values are going to be, again, the probability of getting something at least as extreme as your test statistic, C naught. Okay, that's p-values. You can use either approach to handle a hypothesis test. So now we're ready to actually go through and talk about hypothesis tests. And again, there's two big categories. If sigma is known, then you can use, there's a few different things that you can do here. So if sigma is known, it's going to depend on the type of hypothesis test that you're going to carry out. You can have a two-sided hypothesis test. That's where your null hypothesis, again, your null hypothesis is always going to be the same. That's just the convention of our author of our book. So the null hypothesis is always going to be that our population mean is equal to some value mu naught. And then a two-sided test is where the mean's not equal to mu naught. And then a one-tailed test is where the mean is less than or greater than mu naught. And if it's less than mu naught, it's called a left-tailed test. If mu is greater than mu naught, it's called a right-tailed test. And the way that these null hypothesis tests work, are going to work is that you're going to compute this value given your sample. Okay, so x bar is going to be your sample mean. Mu naught is the value that you're testing for the null hypothesis. Sigma is the population standard deviation. N is the size of the sample, so all the usual values. And you're also going to have to determine your significance level, how significant do you want the data to be. So remember that the higher confidence you want to have, in other words, the lower significance you want to have, the more robust your data has to be, right? So if you want to be wrong only 1% of the time, that means that you are going to be very, very conservative about what data passes the test versus what does not, right? If you're willing to be wrong 10% of the time, then you're probably going to let a lot more through, right? It's kind of like if you have a fence or a gate and you're deciding on how big the holes are, right? It just determines what's going to get through. Anyways, so the hypothesis testing, you're going to compute your standardized value. This is called a standardized value because you use the standard normal distribution. You determine your significance level alpha, and from there, you can either do the critical value approach where you figure out does your standardized value fall in the rejection region or not. And again, of course, if it falls in the rejection region, we reject the null hypothesis. If it does not, we do not reject the null hypothesis. Alternatively, you can calculate the p-value. This side is p less than or equal to alpha. And if it is, then you reject the null hypothesis. If not, you do not reject the null hypothesis. Okay, that's how it's going to work for all of these. So if z naught is in your rejection region, you reject. Otherwise, you don't. Or if p is less than or equal to alpha, you reject. Otherwise, you do not. Okay, that is hypothesis testing. The story is exactly the same if you do not know your population standard deviation, if you have a two-sided hypothesis. It's just that all the usual stuff gets replaced. So your z's become t's, and your sigmas become s's. And then instead of using the standard normal distribution, use the student's t-distribution. The other small difference is just a language thing. Instead of referring to it as the standardized variable, which is what we referred to it here as the standardized value, here we're going to refer to the studentized value. Again, just reflect that this is the student's t-distribution. Okay, that's it. So you compute these values, you figure out does your studentized value fall in the rejection region or not, depending on your significance level, and then you interpret from there. Okay, that's the overall story. So in our next video, what we'll do is we're going to actually compute some p-values. We'll actually run some of these hypothesis tests. And then in a later video, I'll show you how to find p-values. I'll show you how to find p-values in the next video. But later I'll show you there's actually a built-in R function called t.test. So if you want to go take a peek at how that's going to work, remember that this help button is always available, and you can always plug in whatever function you want. So if you want to use the t.test function, that'll give you all the documentation you need. Just as a warning, the t.test function is really built for not talking about a single population mean, but comparing two populations, right? Does this population or the other population, do they have the same mean or not? If you're talking about Republicans and Democrats, or people in college versus people in high school, if whatever, you're comparing two different populations and you want to know whether their means are the same or not, that's really what this test is for. And so in the documentation, what you're going to see is that you're going to have t.test, x, and y. And for now, there is no y. There is no second population. So you're going to have t.test, x, and then you'll pick your the rest of the stuff just based on the parameters of the test. I have details about what you need for the single one population mean hypothesis test for one population mean. I have documentation for that in the R documents that are available on the Google Doc, right? So all that's available in Canvas. All right, so that's enough for now. So next what we'll do is we'll continue this worksheet and we'll find some actual p-values.